Okay, hi guys. So in this video lecture, we'll be seeing hydrolysis of ether. So let me put down the heading. Okay, so I hope you remember what is an ether. Ether is simply ROR. Okay, so hydrolysis means cleavage by water molecule. So water molecule plus cleavage is known as hydrolysis. Let us take an example wherein we have ROR and we are reacting it with OH minus or H2O. No reaction would take place. Please remember this. This has been asked so many times in JV level examinations, and people do again and again repeatedly mistakes in these examinations on this concept. The reason is RO minus is a strong ether, right? So this reaction will not take place. So if you just look into the stability or more acidity of the product formed, you would understand that why this reaction would not take place. Okay, so keep this thing in mind, that alcohol and ether are stable in basic medium. Alcohols and ethers are stable in basic medium. Okay, and also remember that all reactions of ethers will be there in acidic medium. Takes place in acidic medium. Okay, so let's introduce an acidic medium in the ether. So what do we get if we introduce an acidic medium in the ethers reaction? What do we get? Let's see this example to understand this better. We have a compound like this, and we are putting it in a acidic medium. Okay, so what will happen to this compound? What would be the products? So first of all, the oxygen atom from the ether or the compound will actually attack on the H plus here, and it would form, let's say this is the O18 isotope. Okay, and it will attack on the H plus to form this compound. Now after this compound formation, this bond breaking will take place via SN1 mechanism. So we would have something like this plus and after this it will react with water, the solvent, via SN1, and the OH will actually attack on this carbocation to form this as the final product. Okay, so this reaction takes place via SN1 mechanism. This bond cleavage will be via SN1 mechanism. Okay, let us take another example. Here we have this compound, and we have concentrated HI in excess. So what would the product form? So initially the O will attack on hydrogen atom, so it will form something like this. Next, via SN2 mechanism, what would happen is I minus would actually attack on from the back side on any of the any of the ethyl group. Let's say it attacks on this ethyl group, hence the bond cleavage would be this one, and the bond formation would be between these two atoms. So we would get ETOH plus ETI. Again, as I have mentioned that considered HI is in excess, so what would happen in this case is, again, you would have positive charge on oxygen atom, and the I would actually again attack via SN2 mechanism on this ethyl group. So this is again via SN2. We will get ETI plus water. So in the end, we would be getting 2 moles of ET at I as the major product. Okay. Let us see this example wherein we have pH O18 CS3, and we are passing this in considered HI. So what will happen is, this O would first take H plus from considered HI to form something like this and CS3, and you know that pH I minus cannot attack on pH, because if it attacks on pH, then what will happen is the carbon atom on a phenyl ring will get a partial positive charge, so we'll have a formation of something like aryl cation. So this will not take place. Instead, the I minus should attack on would attack on this CS3 via SN2 mechanism, because also CS3 cannot be broken up as a carbocation because it would be less stable. So SN2 mechanism would actually take place here. So what would happen is we would get something like this plus CS3I. This would be the products formed in this reaction. Okay, so we will have a question in which I will be writing ether when it is reacting with hydronium and when it reacts with concentrated HI, or when it reacts with anhydrous HI. Okay, so what would be the products in these reactions? We will be discussing them. So let's suppose we have this ether. This, okay. So with the hydronium ion, what will happen is, as you can see, that first H will be attacking H will be attached to this oxygen atom, and then afterwards we can actually have SN1 mechanism, and the carbocation positive charge will come on this carbon atom, which our solvent will then take care via SN1 mechanism. What about the concentrated HI? In concentrated HI as well, the first H will be taken up by this O atom, and then the bond cleavage would be there, and the carbocation would be a tertiary carbocation which is stable in water due to the hydrolysis. Hence I minus will attack then on this carbon atom. Okay, so due to the formation of stable carbocation, it will also take place via SN1. And what about anhydrous? Anhydrous HI is nothing but it is devoid of any water molecule, so they are only existing in ionic form, H plus and I minus. No water molecule is there. So if there is no water molecule, then we cannot talk about the stability of carbocation, because when we talk about the stability of carbocation, we are also referring that the stability of carbocation is in a polar protic solvent, right? So because of the hydrolysis of the water molecules, and also because of the inactive effect of the attached CH3 groups, but mainly we are talking about the hydrolysis part. Okay. Okay, so means apart from hydrolysis, obviously the plus I effect is also taken into consideration regarding the stability of carbocation, but hydrolysis is also taken into the consideration. But in this case, hydrolysis won't be there, hence I minus would be attacking on this carbon atom, and we'll have a final product formation, but carbocation would not be formed. Okay, so this will take place via SN2, and we are talking this about after the O will be getting a positive charge after the attachment with H. So this bond will be actually breaking down between C and O, and C and I bond would be forming in the intermediate of the SN2 reaction. Okay. Let us take another example. Here we have, what about this hydronium ion? It would be SN1. Why? Because the positive charge formed on this carbocation will be taken care of by the resonating structures, resonating pi electrons, which can be in conjugation with the carbocation attached on phenyl ring. What about concentrated HI? In concentrated HI as well, we can actually have even if the we are having a carbocation on a phenyl ring, the phenyl rings, the total aromaticity is vulnerable because of the CH2, because of the carbocation attached to it. Okay, so because of that reason, I minus will directly attack on CH2 to break the bond between O and CH, O and C, and thereby also forming a bond between I and C in the intermediary SN2 step. Okay, so formation of carbocation is not that much preferred. If there is an option that the formation of carbocation can be at rest or can be avoided, then it would be avoided, and SN2 reaction will take place here. So in anhydrous HI, there is no question that there will always be SN2 reaction only, because there is no water molecule involved here. Let's take a look at this example. So in this case, again we can get a 2-degree carbocation, so this will prefer SN1. But in concentrated HI, compared to this one and this one, this would be more stable and this would be less stable, as it was a tertiary carbocation and this is a secondary carbocation. So in this case also SN2 would be preferred, because it is not it will not be getting that much stable as a 2-degree carbocation. So SN2 would be more stable here, and I minus will quickly attack on the carbocation before it is forming. So just when this carbon gets a partial positive charge in the intermediate, the I minus will have a bond formation with this carbon and will take that for its product formation. So SN2 would be more preferred over SN1. Okay, and anhydrous HI, there is no option but CH SN2. Okay, let's talk about this case. Here if you form a positive sign here, after this O gets H attached to itself, so for if we actually break this bond, then this carbon atom will be getting positive charge, and this is the 1-degree carbon atom only. So SN2 would be more preferred over SN1. So we won't be preferring a positive charge on 1-degree carbon atom if it's possible that in a solvent, water molecule can actually, or OH minus can actually attack on the positively charged partially positively charged carbon while in intermediate state only. So the attack of water molecule would be something like this, and then the H atom would be getting removed from this complex. Okay, then concentrated HI, it will be SN2 and this will also be SN2. What about this? No reaction. Why? We cannot have any partial positive even charge on the phenyl ring due to the formation of aryl cation. Okay, what about this compound? So in this compound also we cannot have any partial positive charge on this one or on this carbon. On this carbon you cannot have because of aryl cation formation, and on this you have a bicyclo constraint. So in both the cases, in all the 3 cases, it won't react. What about this case? If we have this type of structure, then obviously Positive charge on this carbon will be having 3 degree carbocation, so this will take place via SN1 mechanism. This will also take place via SN1 mechanism because the steric hindrance or steric repulsion of I will actually restrict it from actually attacking on this carbon atom, because it's already having 4 bulky groups attached to itself. So it would be very difficult for having a SN2 reaction or a nucleophilic attack, so it would also prefer SN1. But in this case, as SN1 is not supported because there is no hydrolysis, and SN2 cannot happen because of the huge steric repulsion, so it won't be showing any products. Okay, so we'll look at the characteristic or the summary of what we have discussed in these examples. And the summary is, if there is a formation of 3 degree cation or resonance stabilized cation, then SN1 reaction is favorable. So we'll just write the summary or the 2-3 points of our observation. Those are, if there is a formation of formation of 3 degree cation or resonance stabilized cation, then SN1 reaction is favorable. Second point is 1 degree carbon ether favors SN2 reaction. 1 degree carbon in ether favors SN2 reaction. Third point is anhydrous HI favors SN2 reaction and SN1 is not possible due to the absence of solvation of cation formed in SN1. Okay, so anhydrous HI favors SN2 reaction. SN2 reaction, and SN1 is actually not possible due to the absence of solvation of cation. Okay, so with this we come to an end of this lecture, and in the next lecture we'll be seeing acetals, ketols and hemiacetals and their hydrolysis. So till then, good luck and goodbye.